All right, good afternoon. Today, I'm going to try to show you a different way of doing long division. So yesterday, we worked through problems. Looks like 1, 2, 3, and 8. Here's an example. This is a way to get the long division, but I'm going to show you a different method, and I'll leave it up to you which method you want to pick. But for this method, you still have to recognize we're missing the x terms. We have to put 0x. So I call this the tic-tac-toe method. So we need a spot for 3. So I'm going to go 1, 2, 3. And I need some, looks like about 4 that way. So 3 that way, 4 this way. 1, 2, 3, 4. All right. So what we're going to do is we're going to put x squared plus 0x plus 5 here. X squared 0x and 5. And to make this nice and pretty, I'm going to reduce the font size. That looks like that'll work. Okay. And so here's what we're going to do. We're going to work backwards. So we're dividing. We know we need x to the third. We want x to the third. So we're going to go ahead and put x to the third in the box. And now we're going to work backwards. So this is the process of dividing using a box. So we're going to ask ourselves, x squared times what is x to the third? That'd be x. Now I put an x up there, and part of my quotient is going to be x. Now we're going to take x times x squared, we get x cubed. We're going to take x times 0x, that's 0x squared. We could put 0x squared or just 0, same thing. And then x times 5, that's 5x. All right. Now another useful thing is that when you're adding them and stuff, these go together. So these two will go together to make this. Let's see. These 3 will go together to make this. And these 3 will go together to make that. So when we're looking, we're trying to get 6x squared. I'm going to use black since I already used color. So I need 6x squared. I already got 0x squared. And you add here, remember you add the diagonals. So 0 plus what is 6? That'd be 6x squared. All right, well, we're good. Now we have to go backwards and say x squared times what is 6x squared? Well, that'd be 6. Okay, x squared times 6 is 6x squared. I then take 6 times x squared, get 6x squared. 6 times 0x, I get 0x. And 6 times 5, I get 30. All right, now we can look at our negative 5. So now we need negative 5x. I have 5x, 0x. What would I put there so that when I add them, I get negative 5x? That would be negative 10x. But how? How do you get negative 10x? Well, x squared times what is negative 10x? There isn't anything, so it's going to be our remainder. Now our 30, we want 20, so we're going to have to put negative 10 there. And what happens is this part here, so these two those two right there will be our remainder. So if you take this divided by that, what do you get? The answer would be x plus 6 plus, now remember, you need to do the fraction. And what goes on top? Your remainder. Our remainder is negative 10x minus 10. And that's divided by what you divided by. That's x squared plus 5. Make this a little bit nicer. Dividing all that by that. So there's our work. Over here, it kind of got a little confusing. Remember, since we've already worked ourselves down to a constant, there's nothing we could put there. And so what we had to do was 5 plus 0 plus negative 10 is negative 5. So this was not used, but it was added in. And 30 minus 10 was 20. This was not used, but added in. So that's why those two were your remainder. All right, let's try 5. 5, you know, actually anytime you just have a variable with a number, there's a whole process. And if you're watching this video, I do give you permission, but I'm not going to put it anywhere in the notes. Okay, so this will be proof that you watched the video. But anytime it's simple like that, let's just say synthetic, and I don't know why I'm running so large. Let's just say that synthetic division, which is next class period, is easier. And you'll see why. Anytime it's just a variable with a number, let's use synthetic. Now, on the problem we just did, you can't use synthetic because it has an x squared. But if that was x plus 5, I would just use synthetic division. So same thing here. Since this is like simple, just x minus 3, I would use synthetic division. And again, if you're watching this video, I give you permission to just put that in there. Save yourself some time. This is a long worksheet. If you can figure out how to spell synthetic, which I guess I don't. But yeah. So anytime it's like that, use synthetic. And I will teach you that next class period. So you could skip that one and that one. Again, if you're watching this video, you're gonna love it. Again, that's simple. It's just a number with a variable. So I would use synthetic, which, if anything I've learned from this video is how to spell synthetic. Here, simple, I would use synthetic. Now this isn't the answer, but what I want to get at is this worksheet's long, and so there's a process called synthetic division. And in fact, let me show you real quick. Yeah, I'll give you a preview of next week. Preview, it's really easy. You just go like that, and whatever that number is, you put the opposite, so you put a 2 there. And then you just type up the numbers. So like it's 12x to the 4th, and then we're missing the x to the 3rd. X squared is negative 5. There we're missing the x term, so put a 0. And then we have our constant negative 3. And so what happens, and again, I don't expect you to understand this, but what you do is you bring down this term. So that's 12. And then, so you bring that down and you multiply, and that goes here, so that'd be 24. And then you take 0 plus 24, that's 24. And I'll like, that's 24. And then you take 24 times 2, that's 48. You add those, that's 43. You multiply, that's 86. You add 0 plus 86 is 86. You multiply, and that is 172. You add -3 plus 172, that's 169. I just want to check my work real fast. So again, we had 12 goes there. There we have no x cubed, that's why it's 0. We have x squared to -5. There was no x, that's why it's 0. Constant -3. And then you change the sign to a 2. Okay, bring down the first term, multiply, add, multiply, add. Look like I'm dancing. I'm not really trying to. All right, so here's our remainder, 169. Okay, so what you would say is the answer, because you divided out an x, this is now your x cubed term. So your answer would be 12x to the third plus 24x squared plus 43x plus 86, and then plus, and I would list that as a fraction. And on top, I'd put your 169. And on bottom, you put your divisor to be x minus 2. So the question is, what's the remainder? I'd say 169. Okay, so this is called synthetic, but again, you could just put u synthetic. Let's see. 9, x plus 2 is simple, u synthetic. Easier, it's way easier. That cannot use synthetic. So let's do another example of the box method. Oh boy, this looks like fun. All right, so I need 3 lines this way because it's x squared. So I go bam, bam, bam. Maybe you could draw straight lines. I can't. And then it looks like we need 5 that way. So 1, I can count. 2, 3, 4, 5. And then I have x squared. I should have 3 terms. I do. So I put this as x squared, 2x. The other one is -6. And again, I am going to make that fit into the boxes. There we go. Maybe zoom in a little bit, make it easier to read. All right, so first thing I want that x to the 4th right here. So I'm going to go ahead and put that x to the 4th right there. How do you get x to the 4th? Well, that'd be an x squared. You take x squared times each of those, put it here. So x squared times 2x would be 2x to the 3rd. And I need to change my font down a little bit. There we go. That should work. And x squared times -6 is -6x squared. Now remember, we have this one, this one, this one's going to go here, diagonal. And then to get this, it's going to be this diagonal. And then to get this, it's going to be this diagonal. And then to get -8x, that's going to be this diagonal. And then finally to get 6, what color did I not use? To get 6, it's going to be this diagonal. All right, so let's go back. I have a 2x cubed. I want a 3x cubed. 2 plus what's 3? That'd be 1. So this needs to be a 1x cubed. How do you get 1x cubed? X squared times what's 1x cubed? That'd be an x. You could put a 1x if you want. And then x times x squared is 1x cubed. X times 2x, that's 2x squared. And x times negative 6 is negative 6x. All right, now let's look at the x squared. We got negative 5. We have negative 6 plus 2 is negative 4. We want one more negative to get to negative 5. So this is going to be a negative 1x squared. X squared times what's negative 1x squared? That'd be minus 1. So I take minus 1 times x squared to get minus 1x squared. Minus 1 times 2x, I get negative 2x. What did I do? Oh, over here, negative 2x. Negative 1 times negative 6, that'd be 6. All right, now look at that. We have our 6. We don't need to add anything else. So because we're not adding anything else, and we're at our lowest numbers, we can't go any lower than a number, a constant. So because this is 6 and that's 6, we have no remainder. But let's say that was a 7. Say this was a 7. If this was a 7, then I'd put a 1 right here, which would mean remainder 1. If that was an 8, then I'd put a 2 right there. That means remainder 2. So because we got a 6 and we had a 6, no remainder, what's my answer? It'd be x squared plus x minus 1. So I'd say x squared plus x minus 1. And if they ask, the remainder is 0, okay? What else we got here? Here, use synthetic. Way easier. Here, use synthetic. I would use synthetic on that too. And use synthetic. Now you can still do the box method with this. And actually, I'm going to go ahead and do the box on this. Even though you can use synthetic, the box method is just as good. So I got 1. So I need 1, 2. I need 2 that way. Okay, 1, 2. And I need like 5 that way. So I got 1, 2, 3, 4, 5. What goes here? X. X. Down here, a 2. All right. So again, same thing. Red goes there. Yellow goes there. Purple or fuchsia goes there. Pink goes there. And what else did I don't know what other color. Oh, blue. We'll go right there. Okay. Well, you might need to add more as a remainder. So we ask ourselves 9x to the 4. That's easy. Let's put that as 9x to the 4th. But x times what's 9x to the 4th? That'd be 9x cubed. Actually, I like this way better. The more I teach it, the more I like it. Again, I've never taught it this way before. 9x cubed times x, 9x to the 4th. 9x cubed times 2 is 18x cubed. All right. Yellow, we're on yellow. We're trying to get to 14. We're at 18. This needs to be negative 4. All right, we're there. How do you get to negative 4? X times what's negative 4x cubed? That'd be negative 4x squared. Now take negative 4, get that. Negative 4 times 2 is negative 8x squared. That's always, I like this way. It's fun. All right. I have negative 8. I want negative 14 for purple. So I need another negative 6. That'd be a negative 6x squared. All right, so x times what's negative 6x squared? That'd be a negative 6x. Okay, and then I take negative 6x times x, get negative 6x squared. Negative 6x times 2, I get negative 12x. Now we're to the pink. We want negative 13x. I have negative 12x, so I need another negative 1x. That goes right there. X times what's negative 1x? That'd be negative 1. Negative 1 times x, negative 1x. Negative 1 times 2, negative 2. That's what I have. I have negative 2, so I don't need to add anything else as a remainder. So this is my final. My quotient is 9x to the third minus 4x squared minus 6x minus 1. All right, I don't want to do them all for you, but there's one at the end, 15. You cannot use synthetic division. Please make sure you do this. I hope this video helps. You have your choice when you divide. You could use synthetic. You could use the tic-tac-toe method, or you could do the long division method, which that's what I mean. They all get the same thing. Okay, the only thing is with synthetic, it only works when this part's simple, this one's not simple. But the box method or this, it gets the same result. So it's up to you which way you want to use. I hope that helps. Have a good day, and I will see you soon. All right, bye-bye.